Okay, in this video we're going to do the last step. The first step was to sort of label these arrows. The second step was to calculate the magnitudes using the KQ over R squared. Third step was to find what these trig angles were. And this guy, this vector B away from B, right, is at 45 degrees. A is at 165, right? So we did that with this, right? And now we're just going to do all this vector stuff here. So let's fill this in. Okay, this guy A, right there, toward A, is 7,773.7 newtons per coulomb, and this guy is 19,328.5. Okay, and now we can just do this. Remember that if you have the trig angle, this is just mag cos theta. This is magnitude sine theta. I think that's the best way to just get on autopilot, get the trig angle, then you've won the battle. Okay, so let's go ahead and bust this out here. Okay, so I'm going to find these guys here. Right, so let's find that A, there's A, right? And I want to go A times the cosine of this angle, right? Okay, so, and then alpha C is my angle there, right? Okay, so I'm going to go alpha A times cosine of alpha C, right? And I get negative . Okay, and this is newtons per coulomb. Okay. Now notice I could just type these numbers in, right? 7773.7 times the cosine of 165.96, right? And I would get just about the same thing, right? It sort of rounds off a little bit different once you get to that place there, and that's because, you know, we're dealing with rounding in that place. Okay. I'm going to stick with this because this is, like, you know, stored with many levels of accuracy. Okay, so now let's do this guy here. This guy is going to be the magnitude, which is this times the sine of that, right? Okay, so here's my magnitude times the sine of that angle, right? So the sine of alpha C is where I've stored my angle, and that's 1885.4 newtons per coulomb positive. Now let's take a look. Let's just do a little reality check. Let's make sure we're on the right track. Yeah, this x component here is bigger than the y component. The x component is negative, the y component is positive. We haven't messed up our trig angle. Okay, probably. So now we're all set. We can do these guys here. Okay, and so I'm going to go 19,000. So alpha b, there's that guy, 19,328.5, which, you know, it doesn't have any more digits, so we can use that, right? Times cos 45 is our angle there, and this is 13,667.3 newtons per coulomb, and this will be the same thing, right? Just, if you don't believe me, we'll do it again. Okay, so alpha b sine alpha c, same exact thing. Whoops. Why is that different? Alpha b times the sine. Oh, because it's sine. Okay, sine of 45. Here we go. All right, we're good. 13,667.3. So before I use sine of c, but that's not the right angle. Right? That's, by the way, a common. Students do that too. I did that on purpose so that you would not do the same mistake, right? And now all that's left for this step here is I'm going to add this to this and get the x of the answer, this to this, right? Okay? So I'm just going to do that without using exact values. I'm just going to use the rounded one, 7,541.6 plus, oops, got to make that guy negative. Insert negative, and then plus 13,667.3. Okay, and that's 6125.7 as best we can guess. Okay, now we can add these guys, 1885.4 plus 13,667.3, 15,552.7. Is that right? Did I do that right? I did. Yeah. Okay, and now we're all set. Now we've got to do a magnitude and a trig angle. This is time consuming, but it's not very difficult. Okay, so I'm going to draw the vector as if its tail is on the origin. It goes over 6125, up more than that, right? Here it goes over 6125. The actual vector itself, the magnitude is this guy, right? So the magnitude is the square root of 6125.7 squared plus 15 squared. So square root of left parentheses 6125.7 squared plus 1552.7 squared. And oops, apparently I'm lacking the ability to press the 5 button 3 times in a row. 1552. Okay, 16715.6, right, is what I get for this magnitude there, right? And then the trig angle here is easy. This guy is just like, there it is, right? All I have to do is inverse tan, okay? That theta is tan minus 1 of 1555.2.7, opposite side, right, over 6125.7. God, this is the most, do you feel the excitement? I feel the excitement. We're almost done with this problem. Okay, so inverse tan 1555.2.7 divided by 6125.7. All right, 68.5. Right, and that's the answer that we got before. It looks like there's some rounding here, right? But I'm not really worried because we only have 3 sig figs. We have to say 16,700 newtons per coulomb at 68.5 degrees. This being a trig angle, right? Okay? Thank you for listening.